Okay, first thing I would do is it's quadratic, and I want to get everything in terms of the same trigonometric function. I'm going to say in terms of cosines. So let's write this down. This is 2, 1 minus cosine squared x plus 3 cosine x minus 3. This is going to be 2 minus 2 cosine, still equal to 0 by the way, cosine squared x plus 3 cosine x minus 3. Let's clean it up a little tiny bit. So it's going to be 0 equals minus 2 cosine squared x plus 3 cosine x. And then you're going to get a minus 1. I'm going to multiply both sides by minus 1. You get 2 cosine squared x minus 3 cosine x plus 1. Make some attempt to factor it. 2 cosine x, 1 and 1. Let's take a look at that. And what do you get there? It looks like minus minus. So I'm going to say that for this to be true, the cosine of x would have to equal 1/2. And the cosine of x has to equal the number 1. Well, relatively simple. Like, for example, this one over here, if you want to look at a picture of it, the cosine curve looks like this on an interval, and it keeps hitting itself. So I'm going to say the x there would have to be pi k. I'm sorry, 2 pi k. Let me get my eraser out. Okay, this one's a little more difficult. Let's write that down. And cosine again looks like this over here. I'm looking for the angles that produce a half, and there's going to be 2 of those, all right? And let's take a look at that. All right, the first one is going to be x equals. Let's take a look at that. And for it to be a half, that means it's going to be 60 degrees, and 60 degrees is pi over 3. And that sort of repeats itself every 2 pi k. The other one is going to be in the fourth quadrant with a reference of 60. That means it's going to be 300 degrees, which is really 5 pi over 3 plus 2 pi k. All right, I'm going to circle these as being my solution to the problem. And I'm going to go to k and see how we did. Did we get this one here? We did, right over here. Again, k can be any integer, by the way. Did we get this one over here? I did, it's right over here. Did I get this one? Yep, right over here. Thank you.